Yo, what's up, what's up, what's up? Welcome back, everybody. Today we are working on my video editor, and the topic for today is trying to add an audio waveform to the timeline. So, what are we working on? What is this video editor? We are working on this thing where we stream every day, we upload the streams to YouTube. Maybe shorter videos are better fit for YouTube than like the long VODs. Maybe the long VODs are also a good fit, but maybe we need like a second channel that has like shorter ones. I don't know. It's something I want to experiment with. But when I tried cutting down a VOD, it was like hella painful. It was like, maybe I was going to take like several hours to cut down a video, and it's like not worth it for me. I want it to be short. I want it to be quick. I want it to be efficient. So the pitch is, what if our video editor had like a script that went with it, and that script allowed you to seek within the video editor, or sorry, within the video, just like the timeline at the bottom would. And what if you could kind of like select segments of text and say that I want to include those in the video. You select several segments and you clip those back to back, and that's how you like export your new video. That's kind of the thought. Where we're at right now is we don't have much of an editor, but we do have a little bit of a player. So here's Big Buck Plenty playing an arcade thing. We yesterday added the ability to seek. And off stream, I kind of got it to frame perfect seeking, which is pretty sick. So we're kind of at a place now where theoretically we could start trying to clip this stuff, right? You could imagine we could add a UI here that basically let's set a start and end segment, and we would be able to like actually figure out where those start and end segments should be. The problem is I think this progress bar kind of sucks. Specifically, if we're trying to like clip down this type of content, probably looking for like dead space in the audio is like a really good cue for where something should start and end. So you can imagine that maybe I start over here and I select some text, and it maybe selects some area. If you were to imagine me talking, right, it's like silent, and then there's like stuff, and then silent, right? You could imagine that maybe it selects like here to here, and I want to like clamp that in a little bit. Or you can imagine that like even before this script stuff comes in, maybe I just want to clip stuff, and maybe I want to like zoom in on this bar and have something to look at that indicates position, right? So I'm kind of thinking that before we get to the script stuff, it would be nice to show the audio waveform, make this timeline zoomable, and then add the handlebars to add some clipping, and then we can do the script stuff after. That's kind of my thought. So plan for today is figure out how to fucking render this and get it in here. That's the idea. So plan is approximately, let's get the audio out of the video. Let's try to figure out how to get it down into like a reasonable amount of memory usage, because just back to the napkin math, say that we have 48,000 kilohertz, or sorry, 48,000 hertz, 48 kilohertz audio, times 4 bytes per sample, because it's 32-bit floats, times 2 hours, which are 60 minutes per hour, 60 seconds per minute. That's a big number, divided by 124 divided by 1024, that gives us 1,318 megs of audio data. So that's 1.3 gigs for the timeline. Not worth it. We don't need that type of resolution. So we're gonna have to resample that down to something a little bit more sane. Then we'll have to like create the widget and like get any form of something visible in like an OpenGL context in our window, and then render the audio, make it zoomable. And then I was kind of thinking about like LODs, because like where LOD stands for level of detail. So like, in video games, if you have like a tree that's like really far away, they'll just kind of render it as like a few sticks. But as you get closer and closer, they add more and more leaves, add more and more geometry. The idea being that like things that are close should be in more detail than things that are far away. So we could apply that same concept here, where we could maybe make like, how do I say this? Like you could maybe get higher resolution audio as you zoom in, because as you zoom in, you don't need as much stuff, which means that maybe you have to like regenerate the, like rerun, or sorry, how do I say this? Rip through the whole file again later, in higher resolution to generate that. So we'll see how far we get. The big plans for today. Yeah, I mean, we probably won't make it here. I suspect we will make it here. That's kind of what I think, but we'll see. We will see. Okay, let's get in. Buy more RAM, dude. I mean, 1.3 gigs to show a fucking thing on the screen is unreasonable, no matter how little RAM I have. Like, 1.3, that's just stupid. It should be like, maybe like a few hundred kilobytes, like tops. Like, I don't know. It shouldn't be that much data. Especially because like what you're seeing is like such a small portion of the screen, right? How many pixels is that? Even if you just did like number of pixels across, that's way less than that, right? Because like, really, in reality, you can't see less than 1 pixel of data. So like you should resample to your window width approximately, at least. Do you mind answering questions, or are you just trying to focus on your current plan? Okay, my approach for this is you guys can type whatever you want, and I can ignore whatever I want and ban whoever I want. So you can ask questions. As long as they're not like fucking annoying, then I probably won't ban you, but I'm not going to promise I'm going to answer. Because, yeah, even if you had 128 gigs of RAM, 1 gig to show audio on screen is hilarious. Yeah, I agree. Okay, let's try to extract some audio. So we have like our like video decoder already, and he returns video frames in like an iterator style API. So we like basically pull this decoder with this next function, and he'll return like a frame. And right now we kind of like we basically like limit our polling of this guy based off of the frame time of the last frame we read. So if we like read a frame and he says, I'm supposed to be displayed at 1 second, we kind of just display him right now, which is probably wrong. But then we pull the next frame, we don't pull the next frame until 1 second is up. What we should do here is because it's like so decoupled, we can just instantiate a second version of the video decoder, I think, and then just rip it as fast as we fucking can. Just like hammer it and only look at audio. If we have dual channel audio, like stereo, we probably want to average them or take the max of them, probably, right? Like if we're picturing the usage on the timeline, right, where you have like, something like this, right, and you want to see like it's quiet here and then loud here and then quiet here, right? Probably you don't really care when you're looking at this if it's in the left or right ear. You could also render both ears, right? But these are probably almost in every scenario for us going to be equivalent, right? The only difference would be like I have one channel for the mic, or the mic is duplicated in both channels, I should say. But if we had like stereo audio that was playing back, maybe that would matter. But I think even then, I think we only care about loudness for the purposes of like trying to set cut areas. So probably we take the maximum of every channel. And for now, I think that since our video is so short, right, we're working with Big Buck Bunny, who is, I think, 500 seconds, I think. Let's see if we can see. 590 seconds. So maybe we can just start by taking everything and then deal with the resampling later. So what is this? 590 or 5, let's do 600 times 48,000 times 4. That's it. And then divide by 1024, divide by 1024. That's 109 megs. Dude, that's so much. Is that right? 48,000 samples per second, 4 bytes per sample, 600 seconds of samples. So I guess probably there must be some sort of like compression going on. I guess, yeah, like the I actually don't know how audio compression works, but yeah, I do know that MP3s are compressed. So this is like the raw audio data, takes up 109 megs. That's a lot, but it's manageable. So I'm not going to worry too much about it. Or we could do something like only take the first like 20 seconds or something initially. Then it's only 3 megs. Yeah, maybe we'll limit it at first. So we will I'll have to think about it. Fuck it. We'll take the whole thing. We'll take the whole thing. Okay. So I guess we're going to have some sort of audio widget. That seems reasonable. And in here can live the rendering code, and the rendering code will just need to eat a buffer. He'll need to like create a buffer of memory, populate it, then feed it to the GPU at some point. And then he can drop the CPU buffer. I think that all makes sense. Yeah, so let's just start this in audio widget. That seems fine to me. Maybe, actually, I don't like the idea of calling him widget. The other thing we called a frame renderer, so maybe we'll call this like audio waveform renderer. Audio renderer. I like that. That feels fine. Feels fine. What does he own? So I guess he's gonna have like some function in it, and he's going to return audio renderer. Okay. And right now he's just going to return this. Let's maybe construct this guy in main. I think that makes sense for now. So we'll just kind of say he's going to take in, I guess, the path to a file. We could either try to reuse the first decoder or construct a second one. I think maybe we just reuse the first one. So he's going to take in a video decoder, and maybe we'll make some function that's like extract audio from decoder. Seems like he'll want to compress the samples eventually. I need to look into that. I actually have no idea how audio compression works. I would imagine that it's something Fourier transform related. Right? That's the only way that you could losslessly compress, is you could maybe try to like look for like 440 hertz for 3 seconds is very compressible, where like rendering the sine wave over 3 seconds is not very compressible. So my guess would be that you do some sort of like length encoding of different frequencies. But I think that's not trivial. And I think that probably I'll just sample less. Like what I think I'll probably end up doing, we can get a little ahead because it's kind of fun to think about. I think that I was thinking about this a little bit, and you can imagine if you have like a sine wave, if you were to do like a moving average of this, you would just get 0, right? So that's not good. But if you were to take like the maximum and minimum amplitude in this segment and then write that down, you could render this as like a bar chart like this, right? Where you could say like each section I had like this section had this max and this, or this max and this min, this section had this max and this min, and then just like render section by section, and then you could just sample like however much distance that you want to compress by. We'll see what happens if we get into like LODs. I'm not really sure. Yeah, I don't know anything about audio compression, but for this you really only need the volume, which could maybe be very small. Oh, that's a really good point too. I don't really care about... I think it is still like... At when you zoom in a lot, the volume is like somewhat periodic. So, not sure. We'll see. Okay, so we're going to extract the audio from the video coder, and this is going to give us probably an array list of floats. Seems reasonable to me. We need the decoder as well. Okay. And yeah, okay. So here we're just going to, at the end of this, we're going to say, hey, could you go back to the beginning of everything? I'm not really sure if this is fair, but we'll kind of hope for the best. And I guess this is probably failable, right? Yeah, so we have to like catch... I guess we can't defer like this because I would like this to return, like propagate the error on failure. So we'll just kind of do this at the end and figure it out. It's weird that you can't return errors from defer blocks, but I guess I get it. Yeah, it makes sense. It actually does make sense. So I don't know how you would implement that. Oh, I forgot. I wanted to try changing... Oh, I already did this. Okay, never mind. We were struggling with like memory usage the other day, so I wanted to try turning off build on save and see if that helps with like the Zig compiler not getting blocked as we get into the stream. But okay. So at the end of everything, we're going to seek back to 0. But before that, we're going to have some sort of like return variable, which means out here we're going to return ret. And this is going to be our array list, which we initialize with some allocator, which means that we need to take in an allocator here. which kind of means that we need to take an allocator here. Which means that we need to declare allocator as a type here. Hello. And then over here somewhere, let's just extract the audio here, which means that we need to import this. Yeah, yes. And here we go. Var audio renderer is a audio renderer in it with the allocator and the decoder. This is try, because this can fail. And then for now, we will just say extract audio with the allocator decoder. We'll say that the samples is this. Var samples in this language. I guess const samples probably. And then we'll stash the samples here. Yup. And then here we'll say samples is a stud array list of F32. Yep, that makes sense to me. Which kind of indicates that we need a dinit function, which will destruct these guys. So self, this takes in self is a audio renderer, and then we say self samples dinit. Okay, which means over here we need to say defer audio render dinit. Okay, everything is chill. Everything is chill. Maybe we kind of merge these two sections together and we do the resampling now. I think that kind of makes sense because I don't really want to, like, 109 meg seems like a lot. So here what we're going to do is we're going to maybe store our samples as, like, a sample. Hey, first time on stream, was partially binge watching previous recordings of this process. Hey, man, thanks. Glad to have you. Glad to have you. So the sample is going to be a struct, and he's going to have a min and a max. Yeah, sure. Min, max? Which way do I like this? Max, min? In my head, I'm thinking that the maximum is higher on the graph, which makes me want to put it first in the list, but it's also a bigger number, which makes me want to put it second in the list. I guess it doesn't really fucking matter. Then this guy can record samples. Boom, 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 boom. And then, I guess we just rip through the decoder. So we need some sort of like we need to like detect the sample distance. So we need some sort of like target memory usage. And we'll maybe do it in bytes. And let's do like something that's like calculate window size. Yeah. So as we walk through the decoder, we're going to make some sort of like chunk where we're going to take the minimax, and we're going to move on to the next chunk. Boom, boom, boom. And so we need to find how big those chunks should be based off of our desired memory usage, and the size, like the number of samples in the video. That seems reasonable to me. So this is going to be like, he's going to take in the decoder and the target memory usage, and probably the allocator as well. He doesn't need the allocator, I bet. Okay. And I don't really know what he's going to do here yet. But we'll figure it out. So probably walk the streams. So we'll call this var stream iterator is equal to this thing. And he's just going to go over each stream. And we'll just look for like the first audio stream, I guess, for now. We're not going to worry about like merging channels yet. We can handle that later. So let's see. What comes out of this? We have a stream iterator who returns things about stream. Audio stream info has its sample rate, but it doesn't have its length. But maybe like the whole, I think we have like the total duration of the whole video. So I think we can say the total duration s in seconds is decoder dot duration. Okay. Then we can look for we can walk the streams. We'll say maybe like find first audio stream, which will take in the decoder, and we'll return a stream ID. So then this goes here, and we'll say while stream is, what does stream IT next do? It's like, is it error? Yeah, it's errorable. So we want to do like while try stream IT next stream. Switch on the stream. Switch on the stream. And if it's audio, we do something. And anything else, we just do continue. We don't give a shit. This goes comma here. I guess technically there might be no audio streams, in which case this should return null. And here we'll say var stream ID, or we don't need to set a var here because we can just return null at the end, or return early otherwise. Yes, yes, all of that makes sense. All of that makes sense. We say AS stream ID. Yeah, easy. Okay. That's simple so far. Now, when we calculate the window size... Oh, actually, you know what? We should just return the audio stream here. That makes more sense, because the stream ID is not like... We can't really use that directly with our current abstractions, so we'll return this. Like this, yeah. Yeah. Yes, 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 yes. Yeah, okay. So this needs to come from decoder. And okay, that probably works. So now we can say const stream info is equal to find first audio stream given the decoder. Then we can just rip it, right? No. No. This is calculating the window size, right? So we want to look at the stream info dot, or else return null. I kind of want the stream info to be extracted down here, maybe. And then we can say or else return no audio stream. There we go. And stood log error. No audio stream found. Boom, 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 boom. So then when we calculate the window size, we'll say const window size equal to calculate window size. We'll pass in the decoder, but we'll also, well, maybe we don't need to pass in the decoder now. We can just pass in stream info and runtime. Yeah, okay, so this is going to take in, oh, and the target memory, of course, of course. Okay. So he's going to take in those things, which is a... Okay. Stream info, which was a decoder audio stream info. And then we have the runtime, which is a... in seconds, which is a flow32. And target memory usage bytes as a use size. Okay. This is runtime S. We have runtime S comes from this. And it should just be something like stream info dot sample rate times runtime S is something. This is the total number of, this is going to be our memory usage. So const like audio mem usage equal this, and we just say audio mem usage over target. No, target memory usage over audio. So if we want like 300 bytes and it's like 10,000 bytes, we are going to want a window size that's big. So we want audio mem usage over target memory usage bytes, and this is only if we'll just say if audio mem usage is less than or equal to target memory usage, we'll just return 1. Right, because there's no reason to like resample it to be more expensive. That's stupid. We shouldn't do that. Also, that would be difficult. Yeah, and then do we want to error on the size of small or big? Probably the size of big. So this should be like plus target memory usage size -1, so that our integer rounding floors us. So if this is like, if we have like 300 and this is 301, we'll add 299, which will make it 600, which is the roundout. Yeah, makes sense. Makes sense. Yep. Yep. I think that's right. We'll just kind of like round up. And then technically we could, if we really wanted to get crazy, pull this out into a function and unit test it, but I don't want to. You know? Okay, so we have our window size, and then let's just maybe start by logging our window size just to see what happens. Just make sure we're not doing anything fucking stupid. This will run and will extract audio with no samples, which is fine. This should just be fine. So let's just see what it says. Extract audio expected 3 arguments. So audio renderer Zig has alloc. Whoa. Extract audio. It had 3 arguments. Alloc dec, and we'll start with like, I don't know, 300 kilobytes. Of course. Why would it compile? Why would it? Oh, because this is F32, when it should say sample. Sample. What else? Found type, expected type array list, blah, blah. Oh, did I have to write try somewhere? Probably. Curious, you talk out loud when programming off camera? Hell no. This is way harder. Way fucking harder. But, well, I guess I do it sometimes when I'm trying to practice. Because I don't think that, like, I would not want to watch this if I wasn't talking. When I watch it back, if you were just watching me code, it'd be so boring, in my opinion. So I do this. What's it complaining about? It doesn't like that this guy probably is not saying that he can error out. And then this guy needs to write try. And we need to float convert something, or int convert something. So we'll say usize, and then we'll say float from... how do we do this so that we can avoid writing too many as things? We say sample rate times... I think you can do... Well, let's just see what happens if we do int from float here. It's probably not going to be smart enough. We also don't really... Do we want it to do int from float here? We kind of want to multiply the thing as floats. Then cast back to usize at the end. Yeah, so let's do this as F32 int from float, like this. This is going to be an F32, and then we'll say audio mem usage is a usize that is the audio mem usage F cast back. And then everything else should be fine to build. Int from float, expected integer type. Oh, oops. Float from int. Other way. Okay. So we got a window size of 96. If we make this our... So we calculated that this should be like 100 megs almost. So this should be close to 1 if we did our back of the neck and math right, which it looks like we're good at. We're fine. Okay, so window size of 96. That is like an approximate 100x downsample, which I think makes sense. That makes sense to me. Okay. So, now what? Now what? I guess we're going to do something like, maybe it's easier to draw. We're going to have like some, I'm going to consider the array, it's really going to be an iterator of samples, right? So we're going to be coming through the file and we're going to be getting this guy, then this guy, then this guy, then this guy. And what are we going to do? For each window, we're going to like accumulate the maximum and the minimum. So if this, we're going to say like, you know, we're going to have like 0, 10, -10. Not realistic, but whatever. And so here we're just going to walk through and we're going to remember 10. And we're gonna be like, okay, max is 0, min is 0, max is 10, min is 0, max is 10, min is -10. All of that feels fine. So we're just gonna walk through this. We're gonna have a sample that we're accumulating. And then every window size iterations, we're gonna stash it. That seems straightforward. That seems really straightforward, actually. Surprisingly straightforward, even. Okay, so we're gonna like look through, we're gonna go say, decoder next, is that what we do? Yep. While try decoder next. Oh, this is failable. Okay. While true. So we don't really handle end of file very gracefully right now. It just errors out and crashes when we get to the end. So I guess what we'll do is we'll say let, no, not let. What language is this? Zig. Const sample is equal to this, and then we will just catch the error and break if we get an error. And we'll fix me proper EOF handling, which we just don't do right now, but we'll get to eventually. Okay. So he has a sample, and we're going to switch on the sample. Maybe we'll call this frame. I think that's maybe a little bit more of a correct word here, because sample feels audio-like to me. And then do we have to do or else here? Can you chain them like that? I think that if sometimes we call next, and when is it null? Oh, it's only null here when there's an unknown codec type. So this happens if we get a frame and we don't know what to do with it, and then we return null. So I guess in that case, continuing is fine. Catch, break, or else continue. That feels fine to me. First time chat, I like it. It's like you broke the silence to be like, I'm not so sure about this guy. Okay. So now it should be an audio frame. We're gonna do something. Audio frame is fuck. And if we get a video frame, we're gonna just continue, I guess. Didn't know what else to say. Okay, now we're going to check the stream ID. So we're going to say if AF info stream ID, here we go, yep, is equal to stream info stream ID, is not equal, I guess, is simpler. We continue. Oh shit, we actually have to struct these frames actually. So I guess we'll just do it down here. Defer frame deinit. So this way, I don't think that we're going to be like holding on to data that like anywhere, right? Like in the other areas that we do this, where we like pass the video frames around, we have to like give them into a queue and deinitialize them somewhere else. Here, it's like we'll just deinit it in this loop because we're only gonna like look at it one time and then forget about it. Forget about it. We need to have some sample that we're tracking, and he's gonna have like max 0.0 and min 0.0. I think. Oh, that's not how you do in this language. These are equals. Okay. I think this is fine. Usually you would start it with like max infinity, min or max negative infinity, min infinity. I guess that's fine too, sure. Stud math inf. And min is stud math inf. May I ask what you're doing professionally? Right now, nothing. Which is pretty sick. Pretty sick. I used to work in like a. I was trying. Sorry, I was pausing because I'm like, do I really want to say this like every day? And I think I'm okay with it. I used to work with like security cameras, so I did like C++ firmware, C, like a little bit of like microcontroller stuff, but mostly like Linux firmware on like security cameras, which was pretty fun, right? Stuff like you have some like hardware, you need to make it do something, you need to make the lenses move, you need to make the motors move, you need to like extract frames from the DSP. And then I worked in like a neural network company where they said like there's a bunch of shit in a box and we want to figure out which thing from the box to pick up. And you tell the robot where it is, it goes, it picks it up, puts it somewhere. That's the speedrun version. I'm not going to go too much into detail because, unfortunately, I get this question a lot, and it's like it's reasonable to answer it, but I don't know if it's reasonable to answer it for the same people every day. Because, like, you know, a lot of these people were here yesterday when I answered the same thing. So I'll have to think about if I want to address this, how I want to deal with that type of question. What's next? What is next? So here, we're just going to say, here we know that this is a sample for the stream that we want. So can we just look at the, oh, this is a frame. Oh, right. So this is going to have like a bunch of samples inside it, which gets kind of confusing. Because if the number of samples in the frame is greater than or less than the window size, we're going to have to do something different. So I guess we just iterate here. Yeah, okay, wait, that makes sense, So we just do this, and we say, add career command. I need to, yeah, I do need to, like, add bots. I need to figure out how, I've been, like, putting it off because I feel like I should write the Twitch bot myself, and then I look up, like, how do I make Twitch bot? And it starts talking about OAuth and IRC, and I'm like, oh, that seems like a non-zero amount of work, so I just don't do it. But it's not a bad idea, Okay, so here we're just going to store, like, our sample, ID feels wrong. Num samples collected. Okay, yeah, sure, that seems fine. This is a usize, it starts 0. Here we say, defer num samples collected. Or here we'll just say, we'll actually pre-increment. Because then we can do if num samples collected percent window size is equal to 0. We can then like push the sample. And then reset the sample. So we'll maybe do like sample is equal to sample reset or sample init. Init feels wrong. We'll just hardcode it. Fuck it. Fuck it. Is it like this? Is this what they want? Yeah, it is. Boom, 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 boom. And this should actually be fixed here as well. I could split this out, but it's 2 lines of code, and I don't really give a fuck. I don't give a fuck. Okay. So now we're just going to do a sample max is equal to the max of the sample. This is going to be, I guess, I. And so then we're going to do AF channel data items 0 I think. Yeah. So this is 1 array per channel, and then 1 like the index into that channel for this sample. That makes sense to me. So this is gonna be the max of the sample and sample max. We'll do the same thing for min. Except this goes here. Oops. There we go. This is min and min. And sample shadows local variable. Which local variable? Sample. There's no sample in outer scope. Is it just fucking high? I usually say I'm I high, but here I feel like it's high. Never mind. Never mind. Because I'm using both sample for the like outer sample and the inner sample. So, how do I want to call this? Is calling this thing a sample? They're both samples. They're just different samples. One is like a sample of the minimum and maximum in a region, and this is a sample of the audio something at this point in time. So we'll call this item. and then we'll just dodge the problem by writing item everywhere. This has to be built in, compiler built in. We'll log the window size here, and then maybe here we will log num samples collected, and this will be ret.itemslen, and we'll just kind of see what happens. I guess we have to be a little bit careful. What happens if we fucked up real bad and we're going to use a lot of memory? Then stream will die. So we're just going to cut this loop at that's fine. I think it's fine. Just skimming it looks okay. And I'll eat my words. I will eat my words. So this needs to be var frames that we can de-init. And then max. Whoa. Why is item? Oh, fuck me. Channel data depends on the format type of the audio. So this is actually just like a U8 array, but we have to like bitcast the U8 to a float. Which means that we actually probably want to assert. We'll just look for the first audio stream where audio stream dot format is equal to audio. We need to import audio, and then we'll just say format F32. Okay. That way we know that we're working with floating point samples, and then we can just do const item start is equal to this. Times 4. No, item start is equal to I times 4. Mem read it through U32 and then bitcast F32. Could do that. That doesn't seem crazy, but I'm already thinking about it this way. So I don't think that what you're saying is wrong. I just don't want to do it. Yeah. And then we can do item start, item end. So this is going to be the item slice, and then we need to convert the slice to F32. It should be like stud mem as bytes. How do we go like from bytes? Bytes as value. F32 item slice. That seems reasonable. That seems maybe reasonable. Sure. Yeah, I know that I could do subslicing, but I prefer thinking about it as start to end. I'm fine with it. Expected item, expected number found align. Right, so item. Do I need to dereference this? Expected type, this shit show found that shit show. So it looks like it's mad that it's const. Var, we'll write var there. And I'm concerned about how long that was taking. Let's get memory usage logs in the bottom. Okay, that worked. So num samples collected 0. That's not good. That's not good at all. Good eye on this should be item start plus 4. I agree with that. Still saying num samples collected 0, which is odd. Because this should definitely be running. This should definitely be running. Why is it not? Why is it not? I guess debug print got audio frame. Then here we can say num samples, which comes from AF num samples. So he is definitely getting audio frames. And here we'll say stream ID. Maybe here we'll put that log here as well. So he's just never passing that check. But why? One of these guys maybe isn't populated. Stood. Got frame for this. Looking for this. So this is AF info stream ID. This is stream info stream ID. What's it fucking bitching about? Oh, did I forget a new line? I did. I always forget the new line. What's he bitching about? Got frame for 1, looking for 2. So why is he looking for 2? Might be a bug in our stream ID setting. So when we iterate the streams, stream iterator, how do we set the ID? This comes from cint to usize of the stream ID, and then this gets set to stream ID here. Can we maybe just stood debug print stream ID here, just to see what we get? I wanna know. Ah, fuck. Didn't fix our linker problems. Zig's not really doing much of anything. Where's like... Oh, okay. Well, fuck. We should get rid of that other log, I guess. Where was that? That was in audio renderer. We'll comment this out. So this has only 1 and 2. That's annoying. So these are just +1 for some fucking reason? Like the AV stream ID is just not the index into the stream iterate. Oh, that's okay. AV stream FFmpeg. What a weird decision. Oh, what the fuck? Okay, hold on. So this comes from the this is like actually like a index. This is not an index. This is an ID. But here we're probably using it as we're returning it as an index. Yeah, we are. So here we should just return I. And then everything else kind of lines up. And then we'll just put a note here. There is a stream ID in the stream info, but we only care about it as far as we want to index into our streams array. Using the FFmpeg ID is just more confusing and complex. There we go. I think that should make everything make more sense. Have you deleted Zig cache recently? I imagine it grows pretty quick. I don't understand why that would be a problem, though. Like, I don't feel like the Zig cache should, like, make my disk. Because I would think that it should only look up things in the cache that it cares about. Oh, but I guess if it needs to, like, walk the file system in order to find the hash that it's looking for, then, like, maybe listing a directory starts to get more and more expensive. Although I would think that that would happen pre-LLD, but we could do a du.hs zig cache. Let's take a look. 24 gigs? Yeah, that could be it. That's massive. I'm trying to understand why that would sometimes work well. Just because I guess the things that it was looking for in the cache were already in our like file system buffer. Yeah, that could be it. That could be it. Good eye. Thank you. Good recommendation. We'll see how that goes. Especially with the build on save, the zig cache could just be getting like insanely large, insanely quickly too, because every time I modify a file, it regenerates stuff. File system isn't nearly full. It's like I've got like half use, so I think that's fine. But good thought, good thought. I agree. Okay, so we got, how many samples did we pull out? We got zig, build, and do this. Give him a sec, he's got to think. 298112. We fucked up because our window size needs to be divided by the size of a sample. So it was in audio renderer zig. This guy needs to divide this by we'll say const divisor is equal to target memory bytes times the stood mem size of? Yeah. Oh, do I want bit size of or size of? I can't remember. There's a important difference here. Important difference. One of them is like, if you pack them in an array, which we are, it can be different. Here, they'll probably just both be the same size, though, to be honest, but this function returns the number of bits it takes to store T in memory if the type were packed into a struct union. But it's not packed into a struct union. Okay, so maybe size of is fine. Okay, and so then this just becomes divisor -1, and this is divisor, boom. And let's see if that's any different. Why did the window size get... Oh. Oops. No, something here doesn't make sense. Like C++ size of versus a line of. I'm not positive about what a line of in C++ is, but it sounds similar. This should have gotten bigger, not smaller. So I fucked up. I put this on the wrong size. On the wrong side. This would be times size of sample here. And then this is just this. Let's try that. So now my window size should be way larger. 764, because I guess it's 8 bytes per, because 2 32-bit floats. Yeah, that sounds right. Okay. That makes sense. That makes sense. Do we need to store maybe like our sample size in seconds as well? I think that we need this. Unless we can figure it out from what we have. No, you can't figure out from the size of the thing unless you store the duration. So I think this makes sense. And then, so we need to, when we calculate the window size, here we have our const sample size s is going to be the runtime s over the window size, but the last element might not be full. So how do we do this? I guess maybe we want to calculate the window size in seconds first. I feel like I'm missing something obvious here. Oh yeah, it's that we have the window size. Const sample size s is going to be the window size times 1 over the sample rate. I think that makes sense. So if you have like 48,000 samples per second, if your window size is 100, each sample is going to be 1/480th of a second. Yeah, that lines up. That lines up. Yeah, that makes sense. Been binging your videos on YouTube recently, such great content. Thanks, man. That's very nice of you to say. So this is gonna be as. How do we want to do the float conversion here? This way, maybe we'll do like var samples. So this is this float from int, like this, and then sample size s divide equals float from int this. Does this make me, does this like fix all of the as casts that I have to do? Looks like that compiles. And then this guy's just gonna have to say, I guess we'll just return sample size in seconds here as well. Let me think about this for a second. So when we get to the last sample, we need to somehow make sure that we know that it's shorter. But that's okay, because we'll know that like we're gonna have like, you know, even size blocks. And if each of these blocks are 1 large, we know that we've put 4 of them here, and so this is like 4. And so if even the last, we also know like the total runtime, which is going to be like 4.2, which gives us the information we need to like decide that the last box is only 0.2 wide. I think that's fine. I don't think there's anything really to worry about there. Well, there's stuff to worry about, but it's not like unrecoverable. So I think extracting the sample size is good enough. So we'll say here, struct extracted const extracted audio is equal to some struct, and we'll just store sample size s is a f32 and samples is a std. I guess actually this can kind of just return directly our audio renderer. This can kind of just all live directly in init, to be honest. That makes this a little bit easier to deal with. Does it? Here, for now, we'll just return an audio render here. I don't know, man. No, we will, I've changed my mind again. We're gonna take all this stuff, shove it here. Ret is going to be called samples. Here we're just going to define target memory usage bytes is equal to 3, I don't know, whatever this is, 300,000 bytes, which is not the same as 300 kilobytes. Oops, this should be, sorry. Which is not the same as 300 kilobytes, but it's close enough. Right, this is, I guess we could just say 300 kilobytes. And then we'd feel a little better about ourselves, because we love powers of 2. We love them. This now is samples. This is samples, and then we just have to also return sample size s is equal to sample size s. Okay. He doesn't like that because extract audio is still defined, but it does jack shit, so delete that shit. Okay. Okay, sure. So maybe that's fine. Okay, let's, maybe... I'm trying to think if there's, like, some way to, like, validate that, like, the stuff we have is sane before we start rendering it, because that will, like, make some things easier to deal with. And I think we can just maybe print the first, like, 100 samples or something. And that might help. So can we do something like samples items like this? I just want to see see what they look like. I don't know what it's gonna do there. Maybe it's gonna like just absolutely flood my terminal. Oh, jeez. 0, 100. We'll just log 100 of them. I don't need them all. We don't need them all. Min negative 1.2 max. Oh, this is to e to the negative 2, e to the negative 3. Negative 5, positive 5. It does look like they are growing and shrinking, and the min and the max being kind of like almost symmetric in some cases is like a pretty good indication. Like not perfectly symmetric, but maybe good enough. Right, like negative 1.2 e negative 2 and 1.5 e negative 2, those are like similar. So I think that like it, at the very least, it isn't, we don't see like infinities or anything in there. So it's like maybe sane. Maybe sane enough. Just out of curiosity, I'd be curious to see how much faster this goes. If we initially set, well, let's first try making do one allocation here, because I know that the global general purpose allocator can be slow. So maybe we do something like init capacity here with our num samples, which should be const num samples is equal to the window size. How do we do this? This is going to be like stream info dot sample rate times runtime s divided by the window size. Is that right? As f32 float from int as f32 float from int. I think that's right. Okay, and then window size isn't defined yet, so we'll do this here. And then I guess we round up. And then int from float this whole thing. And z size, yep. Gross, but we'll see. So here we'll maybe like say std debug print calculated size is going to be this. You could use append assume a capacity now. Oh, interesting, to go even faster. That's kind of cool. I like that. First, let's just make sure that the actual size matches. Actual size is going to be samples items len. Okay. He doesn't like that because we have to try initialize when we're initializing with capacity, because he's going to actually try to touch the allocator, which makes sense. I'm a little lost. Could window size be named window count, i.e. the number of windows needed to cover the entire video? It's the other way, actually. I think the window size is how many samples fit into one single sample. God, sorry. How many individual floating point numbers go into one sample? 383793832. That's not right, but it's bigger, so we'll kind of call it okay there. And is that still slow? 3, 4. It is still slow. I'm curious to see if this is if we were to do something like optimize equals release fast. Let's just see how much faster that goes, because I don't know where the pain is coming from. I don't know if it's just like, yeah, I just don't know. I don't know where it's coming from. And if it's like something that I need to worry about, or if it's actually fine. Because like 4 seconds for such a short video is a little concerning. That feels very long. Feels very long. 2, 3. And it's pretty slow. I guess it's just FFmpeg stuff. Maybe. I guess it could be something else, but for now, we will keep that in mind as something that could be a problem. There's something to optimize later, but I'm not going to worry too much about it now. Okay, I think we can say that we've extracted audio, and it's been a fucking hour. Holy. That's kind of done. 01, 05, 25. Okay, let's, maybe switch to the allocator. Oh, yeah, let's see if that is worth trying. Let's just see what happens if we do this. We'll do, I think we can just do, this is stood heap C allocator. I suspect that that's not the problem either, because I don't think we're hot allocating in there, but maybe we are. I guess our array list of channels, technically, too. Yeah, I mean, it's not, it's a little better, but not hugely better. 1 Mississippi, 2 Mississippi, 3 Mississippi. Yeah, that's fine. That's whatever. Versus whatever this was. Let's just double check. Ballpark. Counting is not officially 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi. Yeah, it's not that much of a difference. You could say, Mick, you're not supposed to use your fucking fingers in Mississippis to time stuff, but to that I say, fuck you. I can do what I want. Okay. So we have some samples. Let's make a widget now. Let's make a widget. So let's start by git status, git add-u, git add source audio renderer, git commit-m checky, pointy. I will fix that later, but I just want something that I can revert back to if we like heavily screw up. Okay. On our GUI side, he creates a paint callback that says, hey, I'm going to do some form of OpenGL rendering in this box. And I guess we are just going to make another box and do some rendering there. So let's, for now, we'll keep the current progress bar, but maybe we will add after it a something else. So we'll just say, how do we do it down here? We probably allocate a rectangle. Yeah, so this is UI max rect, which isn't really what we want. This can go down by where it's used as well. We're just gonna do all of this same shit. Probably. We'll figure it out in a second. Our rect is gonna be maybe like rect. Fuck. I forgot I turned off the Rust analyzer because I was worried about like swap usage, and the Rust analyzer was just absolutely murdering my RAM. So we do just have to, you know, figure it out ourselves, what we're allowed to call. So what's on rect here? Max and min. So we're gonna do, I guess we want to do more like allocate rect, maybe. Allocate space, reserve this much space and move the cursor. Yeah, okay. So UI, allocate space. Didn't you want to buy some new RAM? I should do that, yeah. eGUI vec2, and we should be able to say like UI.available width and UI, and maybe like 300 pixels tall. This will return us a rect and an ID. And then we can just do the painting in the rect. So we'll start now by let's start by just saying, as like a meme, we can actually render the video again in this segment just to make sure that we've like allocated the right area, which is kind of funny. So if this works correctly, oh fuck, of course not. Of course not. Cache priming enable false helps for Rust analyzer. Yeah, I was reading about that today. I just didn't get there. I was going to try it, but for now, I'm just fine doing this. So if this works correctly, we should see a duplicated video in the bottom half of this. Okay, so it's... I expect this to be small? Oh, maybe 300 pixels is just way too much, to be honest. Let's try like 30. Maybe we should disable the audio. Okay, wait, okay, so that's kind of funny. So it looks like we do have an OpenGL widget that we can render down here, which is pretty cool, pretty cool. It is just the video right now, but we can fix that up. And now I guess we need to... how do we want to do this? We will make a new... We have our audio renderer object already. We just need to expose a C interface to it so that we can access it from the Rust side. So here we'll do... This renderer should be renamed frame renderer everywhere, because now we are going to have an audio renderer as well. So that's probably going to break all sorts of shit, to be honest. Shockingly, it doesn't. Oh, because the type... That's a little spooky. Oh, because the bindings automatically pull it in, and we were using it as C void here, so it's totally fine. This should actually probably be C bindings frame renderer, to be honest. But turns out everything's fine there. And then on the Zig side, our frame renderer was already probably exposing himself as this, so it's totally fine. Okay. So maybe this initGL and deinitGL, they feel like we want the same interface, right? When the GUI starts up and has an OpenGL context, he'll want to feed that into our audio renderer widget. I think that sounds the same. Which means that in our audio render here we'll just kind of, maybe where it says frame renderer, replace this with audio renderer. And then self will come in as audio renderer. Appreciate the NeoVim snippet. Looks like you just chuck in cache priming equals enable false. Cool, cool, cool. Thank you. I will take a look at that at some point, probably. Probably. Okay, so what does this guy want to do? He's going to want to render knowing the width and the height. Does he need those things? Let's think about that. Probably not, to be honest. I think we don't need width and height here, because the waveform will just normalize it so that the top of the widget is 1.0 and the bottom is negative 1.0, and however they resize it is however we'll display it. I think that's totally reasonable. initGL, we are going to use this to probably create a buffer that we upload samples to the GPU with, so I think that's fine. deinitGL, again, we're going to need to clear some shit up. So I think all of this makes sense. All of this makes sense. Now we just need to make those functions, as well as expose them to the other guy. So this is going to be audio renderer. So everywhere we have frame renderer here, frame renderer goes to audio renderer, and frame renderer goes to audio renderer. Boom. Which means that this guy needs to have an audio renderer. And then here, now we want to call into the audio renderer in this new paint callback, which is this one. So where we had renderer before, everything that used to be self-renderer, this needs to now be self-frame renderer. And renderer here needs to be a frame renderer. Boom, boom. this should also be called C bindings frame renderer. Okay, does everything still build? Nope, because there's some places where I still call it renderer. 236. What? 236. Oh, here. Frame renderer, okay. So anywhere else? 239. Frame renderer. And then that's it, I think. I think that's it. Okay, now they're mad about the missing functions on the Zig side, which is fine. We'll fix that up in a second. Maybe for now, on the Zig side, we will just replace these functions here with a std debug print init gl d init and render. And then we have to do like this equals self and this equals GUI GL. Okay. So that should compile again? No, it's too hard because print statements have to have arguments, even if the arguments are empty. Okay. This must be walking some library paths and like just like absolutely tanking memory somewhere. I don't know where. Or disk, I guess. It's annoying. Okay, so this is still calling into the frame renderer. Oh, but that's because our librs we are still calling to the frame renderer. So now I guess our GUI-GL constructor needs to take in the audio renderer as well as the, or not GUI-GL, our GUI object. Here he takes in a frame renderer, and he should just also take in an audio renderer. Which means that over here, this guy is a frame renderer. Yep. And then we just also need a audio renderer. Here. Oops. What did I just do? I just went back to a different file somehow. I just clicked some button that I didn't mean to. Okay. Now we're gonna have to stash the audio renderer over here. Which means this guy is going to have to be audio renderer. I guess we can reuse the renderer pointer thing, even though it's kind of fucking wrong. The types happen to line up, so I'm okay with it just for now. Fix it later if we need to. This is frame renderer is a frame renderer, and an audio renderer is an audio renderer. Riveting stuff. I know. Okay, so this guy has to stash the audio renderer here. And then just on update now, where we were calling the frame renderer here, we can call the audio renderer. And this is audio renderer render with no width and height. This is using the audio renderer. Feels like we're chilling. Let's see. So what we should see now is we should see nothing in the bottom. Well, we should see it compile. Fuck my life. Our audio renderer, we said we don't want width and height here. Not quite, because mute and const at librs81, of course, you always need to specify your mutes and your consts. You know how it is. Here we're missing GUI run, expected 3 arguments at main zig, which makes sense. GUI run now needs to take in the audio render as well. All right, piping complete. As long as nothing goes hella wrong, we have render audio GL and nothing's happening. So now what we want to do is maybe we want to make sure that like all of the state is getting passed around correctly. So what we can do before we do anything is we can just set a clear color here as a member. Maybe we make it, we'll just say clear color R. Here, we'll do this. This will just help us prove that we are correct. So down here, if we allocate these things here, if we fuck this up, then the color we write here won't be what we see on the screen. But if we have like 1, 0, 1, I guess maybe we'll do like green. We'll just make it green because then it's easier. Then we can say that on render, we can call GUI-GL. Oh, did we actually lose the clear? We actually might have. Because I didn't end up needing it. GUI-GL clear color is going to have to take in RG float here, sorry. GL float R, GL float G, GL float B, GL float A, and then GUI GL clear. And this takes in, I can't remember. I think it's I think it is some GL bit field. There we go. And unfortunately, we just have to re-implement these guys. But luckily, it should be quick now. We're kind of familiar with the pattern. So no mangle, X turns C, GUI GL clear. He takes in his context as well as his mask, which is a GL bit field. Which we should be able to just call context dot. I guess we need to look at the glow docs, which are the OpenGL bindings in Rustland. Clear. So this is just mask. So clear mask, easy, and clear color should be the same. Color, he takes in R GL float, G GL float, B GL float, A GL float. And this is clear color RGBA. Okay. If that all works, we should see whatever color we specified getting clear here. So I think we didn't actually execute the clear color here. Why isn't that a vector? I don't know, man. So GUI-GL clear color, and we're gonna use self R, clear color R, self clear color G, self clear color B, 1.0. This needs the GUI-GL here. And then this needs to come from CLand, and then we say GUI-GL clear with the GL color bit or something. I don't know. It's gonna yell at us, but we'll see. It's gonna yell at us for all sorts of stuff, but we'll let him yell. GL use program. I fucked up something at GL exports 204. I must have copy pasted something that I wasn't supposed to. Here I've got some open brace. Probably what it's complaining about. Clear color, method not found in const context. What the fuck? Oh, because I have to dereference. Oopsies. Oopsies. Oh, star context probably. Oh, yeah. Good eye. You are right. Use the undeclared identifier C. That would do it. So const C is equal to import czig. And then GL clear, it's color buffer bit. Not color bit. So hopefully we see a green blob there in our section at the bottom. He's got to pull out all the... Yeah, okay, that's a really good sign. That's a really good sign. Well... Oh, it's, well... It's weird that we lost the progress bar, but maybe that's just what happens when you type GL clear. So I'm not going to be too worried about that. I'm not going to be too worried about that just yet. Maybe eventually, but not yet. So that means that the audio renderer is getting passed around correctly and making it back into the render call. And now we just have to figure out what we want to do with this guy. So my thought is we are going to essentially draw a set of vertical lines here. And they're going to get packed so tightly together that they're just going to look like one big blob. Right? And so what we have to do is we have to upload our samples to the GPU and hopefully pack them. So probably there's going to be some fragment shader or some vertex shader. Some vertex buffer, and we're just going to basically iterate each of these guys. Then we're going to ask OpenGL to draw lines. I think that that's something that exists. GL draw arrays, I think is what it's called. GL draw arrays. And he can take in GL lines, where I'm assuming that GL lines is sets of 2. I assume. GL lines. GL lines. GL lines. 0 and 1 are considered a line, 2 and 3 are considered a line, and so on. Okay, cool. So we should just be able to rip our floats into an array that we stick onto the GPU. Then we should be able to call render GL lines. Yeah, okay. Let's just see what happens if we do that. And since our lines, our floating point samples are already normalized in the range of -1 to 1, we don't have to do any vertical adjustment, but we are going to have to tack on horizontal data to them, I think. Okay. Well, I guess probably what makes more sense actually is probably start with compiling a program that takes in vertices. So let's maybe start by just copy pasting. Sorry, my brain. We can maybe start with something similar to the frame renderer vertex shader and fragment shader. So the vertex shader for the frame renderer just kind of hard codes the corners of the area. And then the fragment shader does a bunch of shit. Maybe we'll just copy paste this stuff and we'll call this audio renderer. Maybe for now we will start with the same vertex shader and we will replace the fragment shader with basically something that just spits out one color. Let's think about this. So we'll spit out a... Yeah, maybe we'll just call it RGB. Let's get crazy. Okay, yeah, and what's our vertex shader look like? He exports just the vertex coordinate, which I think is fine. Taking in the vertex coordinate makes a lot of sense. Outputting a fragment makes a lot of sense. So we can do... We'll eventually have to deal with this frag chord, but for now we don't actually need it. So all we're going to do is we're just going to export our fragment to match our uniform. And then we can compile this shader, run it, and then make sure that we can get our clear color working that way. I think that'll make sense. That'll make sense. So frame renderer has a bunch of compilation stuff. Do I want to extract any of this code into something common? Not enough to actually do it. So we will copy paste, and we will get yelled at by the anti-copy paste gods. They'll be like, don't fucking do that. And I'll be like, you're right. You're right. But also, fuck you. You know? You know? I'll deal with this later maybe if I feel like it. Maybe I won't feel like it. I mean, that would be totally fine as well. You know? So here we compile our vertex shader, we compile our fragment shader, we compile and link our program. We don't have any texture shit to deal with. We don't have any of this stuff to deal with. We do need to write down where our program is, which means that we need to store that guy over here. Boom. Which means that on dinit, we have to delete our program, probably. So we'll just copy this, shove it here, and only do this, and this guy is an audio renderer, boom, boom. Which means that in initgl, we call initgl with GUIGL, and here we call dinitgl with GUIGL. Boom, boom, boom. Everyone is happy. Yeah. And then when we render, we are going to use our program. Hold on. We're going to use our program. We are going to set the uniform of each of our R, G, and B. So this should start with R. With we'll start with 1, 1, 1. I guess we can even use actually our self-clear color R, self-clear color G, self-clear color B. And then we can call draw arrays with a triangle strip of 4 for now. We will fix this in a second. And then here we call self-render. So if that all worked, we should end up with a green box on the bottom half of our screen again. I'm not really sure if it is right, but we'll see. We have to wait 4 seconds for it to rip this. Now, he doesn't like that because there was an unwrap at GL exports 198. So he doesn't like our ability to use the program. Maybe give yourself a break. I don't know how you do 2 hours of talking and coding. Yeah, it does start to get tiring. Sometimes, I don't know what it is. There are some days where it just keeps going totally fine, and then some days where like I feel like my energy level just kind of like drops off at some point, and I don't know what causes it. It's a little annoying. But we'll live. We live. Why? Okay, so why is this not working? Why is this not working? Probably, to be honest, because we never called initgl. That would probably do it. So wherever we initialize our frame renderer, somewhere we call frame renderer initgl. So we have to do this for the audio render as well. Yeah. And then wherever we initialize them, we have to do the same thing as well. Which would be here. And this is init. Maybe that'll fix it. Maybe that will fix it. Maybe not. Maybe she's born with it. Okay, that's really good. We have a green box here, and it's actually filling up the right amount of space too, which is a really good sign. It's no longer overwriting our pause and play button, so we're on the right track. Let's go back to our audio renderer and change some of these values to like make it blue, just to make sure, just for safety, you know, and to make ourselves feel a little good. Cool. Okay, so that's definitely working. That's definitely working, which is a good point to add -u and get commit -m checkpointy ointy. Okay, so now what we have to do is we have to, on GL initialization, we have to create our vertex buffers. Which requires a little bit of refreshment on my part. I don't really quite remember. So I remember there's a vertex array objects, vertex buffer objects, element buffer objects. I think that's it. We probably don't need an element buffer. we probably need both of a vertex array and vertex buffer. We probably need both of those. If I remember correctly, which I probably don't, right? Just a reminder that you guys shouldn't take what I say as like me knowing what I'm talking about. We're kind of just, we make stuff up as we go. But my memory is your vertex shader has some sort of input. And he's going to have like maybe like, you know, vec3, and that's going to be like some point in 3D space that the vertex shader is working on. He's going to work on each vertex individually. In our case, it's going to be probably vec2 for xy position. Now, if I remember correctly, the vertex buffer object is essentially we just write down like x, y, x, y, x, y, and the vertex array object says, hey, so you have like one input here. This guy is like some named input, and your named input starts here and iterates every 2. Are we talking GGL? Yeah. So that's my recollection of what these two guys are. I could be wrong. Let's maybe look up a learn OpenGL hello triangle, because I think that they probably have an example in here that we can just rip. Getting started. Hello triangle. So stride is how you said how much it iterates. Yeah. I'm just trying to remember like where like I'm more trying to think like conceptually where do each of the concepts live, because I was trying to remember what the buffer and array objects are. So here, vertex buffer data, yeah, right, this is just packed floats. And they say, okay, we have enabled some attribute at location 0. We have something of size 3, probably floats that are non-normalized, if I remember correctly, with strides of 3 floats apart, but offset 0. Hand wavy, that's how I remember it. So somewhere they must set up their vertex buffer object as well. Bind buffer, buffer data, here we go. This is what I'm looking for. This is what I am looking for. So we haven't actually exposed any of this stuff from our like GUI GL abstraction layer. So I guess we have to do that. So we need bind buffer data. Okay. So let's look at our GUI.h. We need this guy. We need GUI GL bind buffer. We need buffer data. We need vertex attribute pointer. You also need bind vertex array. Bind vertex array. Yeah, that does seem like we will. I don't know why it's not in here, actually. Oh, he doesn't have a vertex array object. Oh, here he does it down here. Okay, yeah. Bind vertex array. Bind buffer, buffer data, vertex attribute pointer, enable vertex attribute array. And then we need to like allocate the array and object somehow, which I guess I'll look at the glow docs for that, because create vertex array, because if I remember correctly, often the OpenGL calls let you batch create like 10 of them at once, but the glow bindings only let you create 1 at a time. So following this feels a little more reasonable. So we need to have create and delete of vertex arrays and buffer objects probably. Create vertex array. Delete vertex array. Delete. And then create buffer, and I assume there's a delete buffer. Yeah. Yep. Okay. That's a few functions to sub out. But it's okay, we'll leave. So create buffer must return a GL uint would be my guess. We can look it up. Create buffer. I guess this isn't where we're going to look it up. We're going to look it up in GL create buffer. GL unit. Yep. This is going to be GUI GL. And do we need to like make a type of any type? No, we don't have to pass in any type, so that's fine. This is going to take in GUI GL star as well as our... This is going to take in our buffer ID. Bind buffer is probably going to take in the same shit as delete buffer. Unless we need to specify how we bind it, which I think you actually do, if I remember correctly. Target, yes. So this is going to have to take in a GL enum target. Okay. And then GUI GL buffer data. What's in here? What is in here? This stuff. Okay. Target, size, data usage. Okay, that's fine. It's fine. Create vertex array is going to take in GUI GL. Delete vertex array is... This is going to return a vertex array ID. And this is going to let us destroy it. So GL uint vertex array ID, I guess we'll call it. Bind vertex array. Vertex array. Bind vertex array, which is just the ID. So that's same arguments as this. GL vertex attrib pointer. What is I and L pointer? I've never used those before. What are they? Specify location of a blah 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 at index blah blah blah. Attrib I pointer, only the integer types are accepted. If normalized or true, why would... Okay. I mean, if this has a type associated with it, why would I use these? Okay, well, whatever. There must be a reason, but I don't have to worry about it. We'll only pull in the one I've used before. Oopsies, I don't want to select all, I just want to copy this. GUI GL star GUI GL, and then we'll just paste in the rest. And then join. And enable vertex attrib array or something. Which is the index. Okay. All right. Hopefully this won't be too painful. These should be pretty easy. None of these are crazy. The one without the I normalized int min to int max to 0, 1, but only if you specify true for the only if you specify true for normalized, I thought. So, not really sure, but it's okay. I'm sure I don't have to worry about it. He said, later regretting his words. Okay. So I guess probably it makes sense to start by... how do I want to do this? I guess we'll copy paste another function. And then we'll call this GUI GL create. Create buffer, takes in this thing, returns a GL uint, and this is just context create buffer unwrap. 0. Maybe? Zig build? Expected U32 found this because I put a semicolon there when I shouldn't have. Into. Okay. Well, that compiled, which bodes well for the rest of them. That felt very quick and easy. So we can just rip the rest. So this is going to be GL delete buffer. He's going to take in a buff ID as a GL uint, which we're gonna be able to call glow delete buffer. It might be destroy buffer, but we'll figure it out. And then he has to convert this back into a glow native buffer by doing buff ID try into unwrap. And I know, fuck unwraps, but I'm feeling lazy. Okay. Bind buffer next. So, did I fix something up there? No? Okay. GUI bind buffer, and he is going to take in context, the target, the buffer ID, and return nothing. Cool. And that's just going to be context bind buffer. We're going to have to construct the buffer or turn the buffer into a native buffer, which is fine. And we're just going to look at the glow thing. And what is it? Bind buffer, target buffer. And he also needs to be sum. Uh-huh. And target is just the same thing passed through. Does that compile? Bang keyboard. It's a Durgod K320, but if you're asking because it's quiet, it's not quiet. I've just got like a neural network noise gate on here, so it like tries to filter out things that aren't me talking. So I wouldn't buy it based off that. It's also like, I don't know if you would, I wouldn't really trust any of my purchasing decisions. Some people do a lot of research before they buy stuff. I'm more of a just like pull the trigger and regret it later kind of guy. Maybe you'll notice that from my coding practices. Did you build that yourself? The keyboard? No. I just bought a keyboard from the internet. And I wanted one with no number pad because I wanted more space for my mouse. And that's kind of about the extent. Oh, the neural net thing? Oh, no. It's just, I have something called Easy Effects. I would open it up, but sometimes when I open it, it just like fucks up the mic. But it's like some like pulse audio filters that are just like built in, and they have, one of them is like noise gate, which is noise. Okay, create vertex array, which is going to look very similar to create buffer. Probably we can just copy paste all of this actually. All of this stuff. And maybe s buffer vertex array and s buff ID to a what did we call it in the header? We called it array ID and native buffer to native array. And I wonder, well, we could dream because the bind doesn't have a target. Bind does not have a target, which it's a good thing that didn't compile because that's fucked. That would have just segfaulted or something. Native array not found. Okay, so is it because I spelled array wrong? No. Bind array vertex. Bind vertex array. Self vertex array. Okay, wait. So why doesn't native? Oh, it's because it's native vertex array. All right, good sign. Good sign. Let's double check that we got the function signatures right. So create array, GUI GL, delete array, GL uint, bind, GL array ID. Cool. Vertex attrib pointer. Okay, only two more. Only two more, guys. We're getting there. We are getting there. Hell yeah. Okay, this one is vertex attrib pointer. He takes in a index, size, type, norm, and a stride. GL size I, and a P is a const void, C void. Alternative title: adding unsafe Zig code to my Rust codebase so I get the awful syntax combined with the unsafety. Hell yeah! I mean, you're not wrong. It is kind of that. Is this C? This is C here on the left, but we're using C as a FFI, foreign function interface, between Rust and Zig. So there is a little bit of C, but not for any real use. Do you use FFmpeg anywhere? Yep. And our decoder is using FFmpeg. I should actually write here, actually. Dependencies. We have eGUI in Rust for UI, FFmpeg for decoding, mini audio for audio playback. I think that's it. What else is there? Yeah, that's it. That is it. Okay. Vertex attrib pointer. Was its API confusing? Like the API between Rust... Oh, or for FFmpeg? It was fine. It was like the docs are kind of shit, but the API is like not the end of the world. Okay, so I guess we just call this is ooh. So here their functions are trying to be type safe. Where's the data? Oh no, this is fine. This is fine. No, this is fine. This is what we want. So this is context, vertex, attrib, pointer, F32. Have you implemented forwards and backwards in the video yet? Yeah, we did that yesterday. So if this compiles, we can show you actually. Since it's fun to show. Zig build and this is doing some shit right now that we're wasting some time, but it's fine. But yeah, look at that. It's frame perfect. Oh, baby, look at that. Oh, yeah. Oh, yeah. Isn't that fun? So if you want to see that, it's on GitHub and YouTube. Those are links in the Twitch description. Man, I slur the fuck out of saying Twitch description every goddamn time. It's so hard. Okay, vertex attrib pointer F32. So you're going to take an index, which we have here. So we just have index. Size is size. Type is type. Norm is norm. Stride is stride. And then we just have to do offset is this pointer thing. So I wonder if we can just do like p as usize or something, if that will compile. Mostly for chat. The data is implicit in the currently bound GL array buffer. Oh, right. Of course. Why are they asking for a try into unwrap here? Oh, because offset is I32. Can I just say P as I32 then? Is that like fine? Is that gonna... that seems like a cast that shouldn't be allowed. Expected bool found U8. So here we can do norm is greater than 0. But otherwise, it's kind of surprisingly compiled. I didn't really expect it to be honest. Little guy has to think again. I wonder where... Okay, let's see if the hypothesis that Zig cache is really big. 4.8 gigs, that shouldn't be too bad. It was like 24 gigs earlier today. When I ran IOTop before when this was happening, I didn't see any indication that my disk was being slammed, but the fact that DU is taking so fucking long here on Zig out is like a really good indicator. Like, it just feels like my whole disk is just slow, right? Like, he's statting incredibly slowly right now. Can we look at free H? Swap is relatively unused. We do have like 10 gigs of stuff cached. I wonder if like something, like we're just touching so many files that things are getting evicted from cache and I usually just don't notice because so much stuff is in cache. That seems possible. But I would think that my like NVMe SSD is like totally fast enough to manage this. So there's something happening that I just don't understand and I wish I did because it's annoying. Pisses me off when things are slow. Pisses me off. check global cache, like the Linux global cache. I don't know how to check it, to be honest. Don't know how. I'll probably just look into it off stream again. So it does have to get fixed. GUI-GL enable vertex attrib array. Cache zig. Oh. Oh. Well, that's not too bad. 545 megs. And also the fact that it's slow in linking, and also that it's slow when I'm just trying to like list directories is indicating something else, I think. Could be wrong. GL enable vertex attribute array just takes in the GL uint index. So this would be context. And then enable vertex attribute array. It's your being my setting. It does feel like it. Yeah, for sure. Enable vertex array attrib index. Okay. So this should be everything that we need in order to work with buffers in OpenGLN. So in our audio renderer here, I guess on initGL, we are going to allocate a buffer and an array. Which need to be C GL uints. We are going to say C GUI GL create buffer. And we're going to look at GL, or I guess GUI.h, we have create buffer as just takes in GUI GL. So self VBO is equal to this. Self VAO is equal to the same thing, but for array. Create vertex array. If you have an AMD motherboard, there's a good chance it supports ECC if you said you're buying RAM anyways. I do like ECC as a concept. It's pretty cool. Pretty cool. But yeah, we'll see. Bind vertex array, bind buffer, set the buffer data. So we should just be able to do this here, I guess, right? GUI GL bind vertex array with self VAO. Then we bind the buffer. As GL array buffer. We upload our data. So here our data is not necessarily in the order that we want. We need to attach X data to our samples. So how can we... Maybe for now, before we get too crazy, maybe it makes sense to bind like a triangle or something, just so that we can get something on the screen as like a sample. So maybe what we'll do is we'll say const vertices is going to be like 6 floats. You can do non-interleave vertex buffers if you want. You can? I've never done that before. So you, like, do you do that by setting your, oh, you just set 2 buffers. So you would set the, no. Oh yeah, so you do your, like, attrib pointer 0 would be, like, the Y index, and attrib pointer 1 would be the X position or something, and then you use, like, you set this offset here to be, like, really deep into the buffer, and your stride to be 1 instead of 3 or something. Exactly. Yeah, okay. Do I want to do it that way? I'm okay with just interleaving for now. I feel like that makes it simpler for me. But maybe not. We'll see. Let's just start by using 6 vertices here. And we'll do like 0.0, 1.0, xy, 1, 1, and negative 1, 1, which isn't right. This should be 0, negative 1. Does this make a triangle? It's kind of upside down. Well, it depends on which way is up in OpenGLN, and I can never fucking remember. I can't remember if negative is up or positive is up. Oh, that's fine. Let's draw this and just see what happens. So when we bind the buffer, we should be able to set the buffer data. We have to be careful here. Is size of vertices. Is this going to return the size in bytes? My guess is yes. My guess is yes. GL buffer data. Size in bytes. Yep, okay, so this is going to be vertices len times 4. See, GUIGL bind GUIGL buffer. Hello? What is it? Oh, it's just not auto-completing. Because I haven't compiled it yet, probably. Buffer data. This is CGL array buffer. Vertices len times 4. We pass in the vertices, probably dot pointer here. Yeah, and then CGL static draw. I think that seems fine. Seems fine. And then they set the attributes. So, okay, here I can never remember. Does this bind VAO? Like, does this buffer get attached to this VAO so that when yeah, because down here when we use the program, we only have to bind the VAO. We don't have to rebind the buffer. Yeah, okay. And then here we set our information. So see GUIGL vertex attrib pointer. We are going to use GUIGL here, which we actually forgot to do here. GUIGL. We are going to pass in the index. Okay, let's read the docs here, because this is gonna fuck me. Specifies the index of the generic vertex attribute to be modified. So we're kind of assuming here when we type 0 that the vertex attribute that we care about is at index 0. Really, we should do some sort of like lookup here, but I think we can assume 0 as well for now. We will come back to that as a source of error if we need to. Size is the number of components per attribute. So we're going to use 2 here because we're using vec2s. Type, we are going to say that we are GL floats, probably. Is that what they do? Yep. And then are we normalized or not? I don't really. I think just pass through the data as is fine by me. Our stride is going to be 2 times 4. And here we're supposed to pass in a void star cast at 0. So can I just type in null here, I guess, is kind of what we would do in Zigland. That feels right to me. Okay. And then GUIGL enable vertex attrib array GUIGL 0. Are you literally making your own video editing software? Do you think that I was trolling or like clickbait engaging? This is a video editor. Well, it's not an editor right now. Right now it's more of a player, but we are trying to get it to editor. And editor is a pretty, it's a pretty broad set of features. Like, we're basically just doing like cutting up of clips. Maybe we'll throw some stuff on top later, but I mean, yeah. I mean, I don't think I'm lying. I'm not trying to lie at the very least. Then when we do this, we call bind vertex array. So in our render function, wherever the fuck that is, it's just GUIGL bind vertex array self val. Okay. So let's see this builds. Why would it? Method not found in context. GL exports. I think I misspelled something. Vertex array attrib. 2 T's in attrib. He wants a native vertex array. Hold on. Wait. What the fuck? What the fuck? Oh, I had it backwards. Vertex attrib array. There are two functions. I don't know why there are two functions, and I'm not going to find out because I don't want to. You could say, but Mick, you should, and I would say, you're right, but I still don't want to. You can't make me. Wherever I tried to bind the vertex array, I forgot to write GUI-GL here. Okay, we don't have the fields set, so here we're just going to say VBO to 0 and VAO to 0 for now. Vertices.pointer is not in that thing? Really? Do I just write and vertices here? That's a little sketchy. I'm a little sketched out by that. GUI-GL buffer data doesn't exist. Did we not implement that one? GL exports. Buffer... Yeah, I guess we didn't. It's okay. It's okay, we'll live. We'll just do it now. Everybody calm down. Calm down. No need to panic. We can do it. Okay, so this takes... this is called buffer data. First time chat. Panic! Okay. So this is GL enum, or target is a GL enum. Size is a GL size I pointer. Data is a const void, and usage is a GL enum. Okay. So this is going to have some sort of buffer data call, and we need to look up the glow buffer data. So this is buffer data U8 slice. That makes sense. That makes sense. They're trying to be a little bit type safe. So what do they want here? They want the target, which we can just pass in. They want the data and the usage. So here we can say let data is equal to data stood slice from raw parts. Data as const U8, size as usize. I'm pretty sure that's right. If we get that right first try, I'm going to be like, you know, a little surprised. A little surprised. Const void, right? So void here has to be C void. Wow, it built. I love it when it builds. And I love it when it links fast. Okay, it's just blue, which is kind of surprising, to be honest. I feel like it shouldn't be blue. Unless we left a clear in there. Oh, wait. Are we using the clear color as the uniform? We are. Oh, wait, our array drawing needs to use only 3 elements. So this should be triangle 0 to 3. There's probably just some like uninitialized memory that part of the triangle was hitting before. That's a good sign. That's a really, really good sign, actually. I think that our triangle, we might have put in the wrong... we meant to do 0... Maybe I meant to do negative 1.00 here? I could use my head. But we hate using our head around here. We always say that. I don't know why it feels like the vertices are wrong. Oh, wait, hold on. Is it because I didn't change the vertex shader? That seems possible. Audio vertex shader. Yeah. So here we should be using in vec2. I don't know, in chord. I don't know. Fuck it. And GL position is going to be a vec4 in chord x in chord y 0 1. Yup. And then vert chord 2D output is going to be in chord. And this goes away. I got a little excited there from it working. Because we didn't use any of the stuff that we just implemented, so that's why it worked. Fuck! Failed to get uniform location. At, what, 134? But we don't know. It's one of these, R, G, and B. Audio renderer fragment. R, G, and B should be fine. I'm kind of confused because I would think that if it worked before, why would changing the vertex shader change the uniforms that it could find? You're not using them so they can compile it out, but I am using them. I'm using them here. Is the blue triangle for transition or something? I'm just trying to get something to draw so that I have some proof that it's working. It's possible that, like, when I compile the program, that I'm not error checking. That seems like kind of likely. So maybe let's go to the compile shader. And, like, can I just check an unwrap on here and just see what happens? Method not found. So compile shader is not failable? That's surprising. I would think it is. But it's not. So does that mean that GUI-GL expects me to call... Is there, like, error on here? How does the errors work? Compile shader link program? Like, what goes on under the hood here? They call GL link program. How does error handling work in this fucking library? Mars, thanks for the prime. Appreciate it. Appreciate it. I guess I'm supposed to call this. I guess. Ugh. It's annoying. That's a little annoying. I would have preferred for them to, like, just let me unwrap, but maybe we call get shader info log. So when we compile the shader, we can probably just do get shader info log for this shader, and we just print line this. Just for now for debugging. Uh, 229? What the fuck? I already fixed this. I must have accidentally undone something that I didn't mean to, which is a little scary, but you live, you learn. Well, we won't learn. We live. My guess is that the program is failing to compile. Yeah. Y undeclared. Yes, yes. Okay, that's a really good sign. How do I get out of this? Okay, so this is Y undeclared. Oh, it's because I put a comma here instead of a period. It's a hard life. For us. Life. For us. I know we've looked that one up several times. Okay, so now we have a different triangle rendered. It looks like the fact that we're getting anything is a good sign, and let's just try to see if we can figure out how to make the triangle look like how we would expect. So, I think 0, -1 made sense to me initially. The triangle we originally had, I think, should look like this. We'll see. Come on, buddy, you can do it. You can do it. And then we have to spam the... Okay, upside down, but close enough. So that's another really good sign. That means that we have our ability to feed data into the GUI programmatically, which is very good. That's something that we didn't have before. So now, let's try doing what people were talking about, where they were saying that we could, uninterlace the data. So can we say like x's is this and const y's is this, and we just kind of do -1 1 1. And if I understood what you guys were talking about correctly, hopefully those of you who know what the fuck is going on are still here. You're kind of saying that in the audio vertex shader, I can replace this vec2 in with a float x and a float y. Replace this in chord with x, y. This will be vec2 x, y. And then here I will have two vertex attrib pointers. I'll have 0 and 1. Where here I just need to make sure that it's one element with a stride of 1 times 4. No, the non-interleave thing was only CPU side. GPU figures it out. I'm misunderstanding something then, because I don't really understand. In that case, don't I need to somehow have multiple vertex attrib pointers for the same buffer? It feels to me like I would have to do it this way in order to specify. Okay, no, I was wrong. Okay. So this guy, we just feed them in the same thing, but we just feed the data. We actually still need the data to be contiguous here, huh? Because we need to bind one buffer. Unless we can assign multiple buffers to the same vertex attrib array. Like, can you bind the buffer again here? I'm not really convinced that that works. Because I don't really remember, this is where I remember getting confused about the fact that buffers are bound. Yeah, I'm gonna interleave it. I don't see why you'd want it non-interleaved in the first place. The only reason is because I have like sample data that has like effectively Y positions. Like I already have that somewhere. And so I was trying to avoid allocating another array on top of that, but it's fine. We'll just do it. Like blaze it, you know? God, I shouldn't fucking say blaze it. It's so fucking stupid. Okay. So what we'll do instead is we'll make our vertices is going to be a stood array list of F32s. Like this. With the allocator, we're going to defer vertices DNA, because if I remember correctly, it's safe to delete this data after you've uploaded it. GL buffer data replaces the entire buffer, so if you want two separate CPU buffers, the same GPU buffer, you need GL sub buffer data. Yeah, gross. Not worth it. Not worth it. We're just going to interleave it, because I know how to do that already. I already know how to do that. Okay. So, how are we going to do this? We're going to take our samples. Why the double screen? Just because sometimes I find it easier to reference stuff on the left. It just, I don't know. Just happens sometimes. Okay, so for sample self samples items, we have a sample. And for each of those samples, we're going to push its X position. So we're going to have to keep track of the X position. It's going to start at -1, and it's going to increment by probably the number of samples over 2 as a float. Times 2, actually, I think. Times 2. Because we go from -1 to 1, so if we have 1 over 2, it's 2 over this. That makes more sense, yeah. So over this many samples, we will increment 2 from X norm. And so that will go from 0 to 1. Okay. Cool. Now for each sample, we just push the bottom and the top. Yeah, that seems right. So vertices append We'll do x norm once. Twice. We're pushing 4 things. This is going to be sample min and sample max. Nothing about this seems wrong to me. Okay. Vertices. This is items len now. And I think everything else just stays the same. Then here we want to draw GL lines. And we need to draw some number of vertices, which is going to be like the number of samples that we have. Times 2. Right? If we had 3 XY vertices before, now we have samples min max. Yeah, I think that's right. Let's just see what happens. Let's just see what happens. I think there's like a chance that this works. A non-zero chance? Or sorry, a close to 0 chance, but not a completely 0 chance. So we need to return an error here. So instead, we're just going to, for now, do this, because I don't know how to return an error right now, and I don't want to. But we will have to figure that out eventually. Alloc needs to be defined in here, so when we will stash the allocator here. Okay, so we crashed because cannot construct vec4 from a non-numeric data type. Wait, didn't this work like a second ago? Oh. Oh, fuck. Undo. Okay, that's the state where it's working. Woo! Scary. Still segfaulting. Shader compilation didn't seem to crash. Let's see where we're crashing. It's okay, guys. It's part of the expected process. This is what I expected. This is from... Jesus Christ. Buffer data. Oh my god. Oh, jeez. Ow, my brain. Ow. Where are we? GUI run, new. Init GL. Here we go. GL buffer data. Set line frame 10. So this is from this. Oh, because this is just an invalid pointer. Oopsies. Oopies. Type safety. Who gives a fuck? What if we just fucking send it and then get mad when a seg faults? What if we did that instead? Well, let's not even bother GDBing. Let's see if it crashes first. Actually, let's just, we'll run in GDB because it's gonna crash, and we want to have the backtrace when it happens. No fucking way! Holy shit! Wait, no fucking way! Guys, it worked! No fucking way! Oh, that's so sick. Holy! I really expected it to be worse. I really expected it to be not work yet. God, sometimes it just hits. With OpenGL, I always struggle so fucking much. So this actually makes me like so fucking happy. First try, I mean, you could argue first try, but there was a lot of not first tries in between. Okay. That's pretty fucking sick. That's a really good place to call it for today. I think that we've made some pretty good progress. That doesn't fully align with the seek bar, right? Yeah, it doesn't. I'm gonna replace the seek bar with this widget entirely, so I'm not really too worried about it. Yeah, I'm gonna call it for today. Really good progress. What we're gonna do tomorrow probably is I'm going to try to make it so that I can like scroll on this thing and zoom in and make sure that it tracks the time correctly. So we're gonna have to add some sort of indicator to where we are in this thing. as well as maybe some sort of indicator of like how many seconds are involved in each thing, whatever. There's more to do. But really great progress for today. I'm really happy with that. So thanks for watching, guys. If you like what you saw, we stream most days at around 2 o'clock Pacific time for around 2 hours. Today we hit 2.5 because I'm willing to go a little farther if I'm excited, but we try to keep it around 2. If you're new here, there is a YouTube link in the Twitch description, and in there you will see all of our previous work. So we're working on this video editor right now, but there's other interesting stuff in there: zlib implementation, terminal emulator, git GUI, diff tool. Like diff algorithms are kind of fit in this guy. There's like a 3D engine over here and like an operating system over here. So all that stuff if you want to go check it out. GitHub link in the Twitch description as well, where you can see code for all the stuff that goes up. What else? If you're on YouTube, there should be a Twitch link in the YouTube description where you can swing by and say hi if you're online between 2 and 4 Pacific time. Other than that, we have to plug our shit, so like, subscribe, Twitch Prime, and I think that's it. So goodbye, YouTube viewers and Twitch viewers. Let's figure out who to raid.